All right, our next problem is over here, and we are following our algorithm. We write our t-chart is step 1 and label it statements reasons. So I'm going to do that. I have statements on the left side, and I will have my reasons on the right side. My step 2 is to number the first row 1 and write down the given statements. So given is x is midpoint of line segment W, Y. Okay. My reason is going to be given. And then we move on to step 3. If there's any congruent statements, we convert them to equations using definition of congruence. So are we given any congruent statements? No, there's no congruent statements here, right? So we skip step 3. Now, step 4. If there's a midpoint given, is there a midpoint given? Yes, x is midpoint of WY. That is a given. Right? So what can we do? We can use definition of midpoint to create an equation. And going back to our proof sheet, we have definition of midpoint right here. Right? What does it mean? It means if B is the midpoint of AC, then that means B is directly in the center of A and C, meaning the left side is equal to the right side. Okay? Namely, length of AB is equal to length of BC. So we're coming over to here, and we have x midpoint of WY, right? X is the midpoint of W and Y, meaning x is directly in the center of W and Y, meaning that the left side is equal to the right side. Namely, measure WX is equal to measure XY. That's the equation that we can create. So it's measure WX is equal to measure XY, and our reason is going to be def of midpoint. Okay, there we go. So now what do we do? Well, we're back to our algorithm, right? We went ahead and changed our midpoint into equation. Great, good. What's our next step is here. If you have 3 points on a line in the figure, we use seg-adpos to create the equation. And what does seg-adpos let us say? Let's just say the first part of the segment plus the second part of the segment equals the whole segment. So do we have 3 points on a line in the figure? Well, you might be saying no, we have 4, right? But 4 means that there are 3 there. So yes, we do have 3, right? And so when you have 4 points on, when you have 3 points on a line, like right over here, right? We use seg-adpos. Right? We say first part plus the second part equals the whole part. Measure AB plus measure BC is equal to measure AC, like we did right here. Okay. Now when you have 4 points on a line, like we do over here, you use seg-adpos twice. You use seg-adpos on those first 3 points, and then you use seg-adpos again on the second 3 points. Okay, so that's what we're going to do here. I'm going to go ahead and create an equation with the first 3 points, namely measure WX plus measure XY is equal to measure WY. And then I'm going to do it again over here. Right, make another equation. Measure XY plus measure YZ is equal to measure XZ. So let's go ahead and do that. Measure WX. Remember, when we go to measures, we don't need the line over the top of the line segment. So we go WX is equal to XY. Oh my goodness, what am I doing? WX plus XY is equal to WY. Next equation, XY plus YZ is equal to XZ. And my reason here is going to be seg-adpos. Okay, so we go back to our algorithm, we did seg-adpos, and now we're here. Our last step is substitution. We got to substitute till we get to the proof statement. We got to get to that proof statement right there. So how do we do it? Let's see. We can say WX YZ is equal to XZ. Okay. So what we need to do is we need to replace this XY with a WX, basically, right? If you see these two statements here, they're exactly the same, except this expression is a WX. Right? If we can change this to WX, we have the proof statement. Do you see that? So can we change that to a WX? Right? Well, the only way that we could do that through substitution is if we have an equation that says XY equals to WX. So do we have that equation? Well, we have 3 equations here. We've got 1, 2, and 3. Do we have that equation here? No, we do not. Do we have that equation up here? Yes, we do. Okay, wx equals to xy. So that means I'm going to go ahead and take this wx, and in the place of the xy, I'm going to put wx in another equation. Okay, that's what substitution is. Equation means if I see a xy, I can put a wx. If I see a wx, I could put an xy. So I'm going to go ahead and take this, and I'm going to put it right there. All right. So 4 is going to be wx plus yz is equal to xz, and my reason is going to be substitution. And we're done because this is the proof statement.